today means in the previous class, we have already applied the division, Euclid's division algorithm on two numbers. Okay, that is we find out the HCF of two numbers. Okay, today we will learn how to find the Euclid's division, how to apply Euclid's division algorithm on three numbers. Okay, so Euclid's division algorithm now it is same as the like you apply Euclid's division algorithm two numbers. It is the same in three numbers. Only difference that or only thing that one step is increased. That means like you have three numbers here. For example, 180, 252, and 320. You have 180, 252, and 324. Okay, these three numbers are there. Okay, if you want to find out apply Euclid's division algorithm on three numbers, first you will arrange the number in descending order. That is 224 is greater than 252, which is greater than 180. Now you will first apply the Euclid's division algorithm on the first two larger numbers, and when you get the HCF that you get in the end, you will apply the Euclid's division algorithm on that number plus the last number, that is 180. Let's see. Okay, so if you will apply Euclid's division algorithm on 324 and 252, then what you will get, divide by 1, 2, and what you will get, the remainder will be 36, sorry, 272. Okay, now another one will be 72, 252. Here, if you will apply, then it will be 3, 216, and what you will get a new remainder will be 30. Then you will apply again Euclid's division algorithm and the new remainder and 72, and here it will be completely divided. So that means HCF of the two numbers are 252 and 324 is what? 36. Okay, now you have to apply this that you have got, that is 36 is the LCM. You will apply the new Euclid's division algorithm on 36 and the remaining number, that is 180. The third number is 180 here, so you will apply in 180. Now if you will divide 36 from 180, then what you will get? 36 multiplied by 5 will give you 180. Okay, so 324, 252, 180, HCF is 36. Okay, so any doubt in how to apply Euclid's division algorithm in the three numbers? Rudronian, are you there, Rudronian? Okay, any doubt here? No. It is same process that you used in two. The main thing is that you have to find the HCF. Okay, but HCF, finding the HCF will be divided in two steps. First, you will choose the first two bigger numbers, and then the HCF that you have got you will use the new division algorithm with on that number and the number that is remaining. Okay, let's check on the example. Okay, now this type of example that is like problem sum, let's check with that. Okay, so here what is saying that there are group of students, three group of students, A, B, and C. Each group of students have different numbers. Okay, A group contains 150 numbers of students, B group contains 206 numbers of students, and C group contains 260 number of students. Okay, buses are to be hired to take them from a field trip. Find the minimum number of buses to be hired if the same number of students should be accommodated in each bus. Okay, now what is there that you have already told that three groups are there. How many students are there in each group, that is also given to you. Now what you have to do, you have to find the minimum number of buses that you need to hire for accommodating all the students. Okay, and you have to take care that in each bus equal number of students are there. Okay, fine with here. Now I want that you should apply Euclid's division algorithm on 156, 208, and 260. Okay, so what will be your first step, here? If you need to you need to solve this question, what will be your first step?
First, you take the two largest numbers.
Okay, I'll just show you the question. Okay, yeah, first two largest numbers. So which two number you will pick?
260 and 208.
Which one?
260 and 208.
260 and 208. Good. So can you tell me what is the HCF of 260 and 208? Can you solve it?
Yes, ma'am. You said 52.
Yes, very good. Now what you have to do, what will be the second step? You have already got one the HCF of 208 and 260. Now what you will do? What in the second step?
You take 52 and 156.
Yes, so apply again the Euclid's division algorithm on 52 and 150. And always when you will solve the question in your examination, always do mention the statements, okay? That we are applying Euclid's division lemma here in 260 and 208. What we got this, remainder is not equal to, we are again taking this, okay? All the steps. You will get all these steps in the notes in your apps, okay? That what the different steps that you have to write, because in examination each step contain numbers. Half number on each step is there.
And I got the answer is 52.
Yeah, very good. 52. Now, this is the HCF of all the three numbers, all the number of means A, B, C group of students. Okay. Now, here your answer is not the you have not got the exact answer. This question is something different. Okay. What it's saying here? Find the minimum number of buses to be hired if the same number of students should be accommodated in that. Okay. So this is the HCF. Now, one step will be added to get your correct answer, or you can to complete this question, that you'll find the minimum number of buses that are required. How you will find the minimum number of buses that are required? You will divide each of the number by the HCF. That means you will divide now what you will do, you will divide each number by the HCF. 156 divided by 52 plus the next number is 250, 200, 208, 208, and after that which number 260. So you will divide each number by the HCF that you have got. Now, if you divide 52 by 156, you'll get 3, plus 52 divided by 208, you will get 4, plus you will get 5 here. Okay. So what will be the answer? 12. So 12 number of buses will be required to accommodate all the students. Okay. With equal number of students in all the buses. Understood? Any doubt in this question, Rudroniya?
No, ma'am.
So these type of question will come in your assignment, or you have already seen these types of question in your assignment. Okay, based on means the main the way of solution will be, a way of solving the question will be this. Okay, so most probably these type of questions come because it is not exactly that you have to find the HCF. Okay, something extra you have to do. Okay, so we have completed the topic of Euclid's division algorithm and Euclid's division lemma. Okay, now always make sure that you learn the complete statement of Euclid's division algorithm. Okay, because that statement come in 1 marks. And what is the exact statement? What are here A, what are B, what are R, what will be the values of R? Okay, these things can come in 1 marks question. Now let's switch to the third topic, that is fundamental theorem of arithmetic. Before I tell you what is the fundamental theorem of arithmetic, we should know some of the terms that are used in fundamental theorem of arithmetics. Prime, co-prime numbers. You must be familiar with prime numbers, co-prime numbers. Okay, have you listened about prime numbers, Rudroniya?
Yes, ma'am.
So can you tell me what are prime numbers?
Prime numbers are like 2, 3, 5, 7,
Yeah.
13.
2, 3, 5, 7. Actually, the main definition of prime number is that the numbers which are divided by itself and one only. Okay, no other number can divide these numbers. Okay, so the factors of these numbers are 1 and the number itself. Like 2 can be divided only by 1 and itself. 3 can be divided by only itself and 1. Okay, and moreover, one important thing that when times it comes or can be asked in a true false, that 2 is the only even prime number. Okay, only even prime number, and this is the smallest prime number also. Okay, and 1 is not a prime number and not a composite number. Okay, now what are composite number? 1 is prime number and 1 is composite numbers. The numbers that are not prime numbers are composite numbers. But what is the exact definition of composite numbers? The numbers that can not only be divided by 1 and itself, it has factors other than 1 and itself. At least one factor should be there. Like 6 had factor 2, 3, 6, 1. Okay, the 6 have factor other than 6 and 1, that is 2 and 3. Understood? 4 has factor 2, 4 and 1. So 4 has one factor that is other than itself and 1. Okay, and 4 is also the smallest even composite number, and smallest odd composite number is 9. Okay, understood? These are the simple definitions, and you should just know about what are prime numbers and composite numbers. These are not exactly going to be asked in your exams, but these terms are used, so you should know the definition of prime numbers and composites. Okay, Vidyalia? Now, what are factors of a number? Factor of a number means that a number, when divide another number completely, then that is the factor of that number. Which, like if you're dividing 2 by 6, if you're dividing 6 from 2, then there should not be any remainder left behind. If there is no remainder, then that number, particular number which is dividing, is the factor of the number to which it is dividing. Okay, like if you are dividing, so if you are taking 12, so 12 factor are what? 12 will be divided by 2. We will start from the smallest prime factor. Okay, prime factor means the prime numbers. Okay, the smallest prime number will start. If you divide 12 by 2, then what you will get? 2 6 are 12. Now again 2. So what are the prime factors of 12? The prime factors of 12 are 2 into 2 into 3. Okay, always express it as a prime factor. You don't write as 2 into 6, because 6 can again be divided into its prime factor, that is 2 into 3. Okay, so always take the least prime factors, 2 into 2 into 3. So these are the prime factors of 12. Okay, now factor 3. Factor tree is nothing but you are expressing or dividing the number, or you are drawing the like the factors, the prime factors of the number, okay, in a form of tree. For example, if I have taken here 12, I'm going to take 24. So the factor tree, just you have to draw it in the form of, so 20, we'll take the smallest prime factor, that will be 2, which can divide 24. So we are going to take 2. Now 2 12s are 24. Okay. Now again, 12 can again be divided by 2. 2 6 are 12. Now 6 can again be divided as 2 3s are 6. Now this is the last. So what are the prime factors of 24? You can see here 2, this 2, 2, 2, 2, and 3. So have you understood? Now prime factor is 2 into 2 into 2 into 3. Okay. So this is the prime factors of 24. Okay. Similarly, you can find the factor tree of different numbers. Okay. Let's find out the factor tree. Okay, Rudronial, can you find the factor tree for 4095?
Yes, ma'am.
409. If 2 didn't divide any number, then you have to move to the next prime lowest factor to divide the number. If 3 is also not dividing, then switch to the next. What?
3 into 3 into 5 into 7 into 13.
3 into?
3 into 3 into 5 into 7 into 13.
Yes, very good, Rudronial. Okay, it's 3 into 3 into 5 into 7 into 30. Okay, this order may differ. Okay, if you're not choosing the smallest one at initial, but these numbers are actually okay. Let's switch to the definition of fundamental theorem of arithmetic. There it is mentioned this. Okay, now what fundamental theorem of arithmetic states? According to the fundamental theorem of arithmetic, every composite number can be written, or you can say factorized, as the product of primes, and this factorization is unique. Okay, that only explained that 24, you can factorize. 24 is a composite number. It has factors other than itself and 1, like 2, 3, and all they have factors. Okay, so it can be expressed, this number can be written as the product of prime numbers. Okay, the other prime numbers. Okay, they can be same, like 2 can appear 2 times, 3 times. Okay, it may happen, but they can be expressed as a product of prime, and this factorization is unique. For every number, there will be a unique factorization. Okay, for some 2 can be used only 1 time, and 3 can be used 2 times, and 5 1 time. For some 2 can be used 4 times, 3 can be used. So this factorization will be unique for every composite number. Okay, but order can be varied. You can write 2 into 3 into 5, or you can write 5 into 3 into 2. Okay, this order can vary, but the numbers will be unique. Okay, the how many times they are appearing. Okay, now let's see. Or you can just simply say that composite number is equal to the product of prime number. Okay, in a simple definition. Okay, composite number is equal to the product of prime numbers. Understood, tutorial?
Yes.
Okay, now let's see these. Now let's express 1001 as a product of its prime factor. Okay, so it is very simple. Like you have find out the factorization here. So here the prime factorization of 1001 is 7 into 11 into 30. Okay, it can be 13 into 11 into 7 also. Okay, but this factorization is unique in itself. 7 into 11 into 13 always give 1001. Okay, now example. Let's see an example that is all that has appeared in NCERT examples and appeared in CBSE 2015 question paper. Explain why 3 into 5 into 7 plus 7 is a composite number. So how can we do that? We have to explain that 3 into 5 into 3 into 5 into 7 plus 7 is a composite number. Okay, we have to say that. Now, what will be 3 into 5 into 7 plus 7? It will multiply this number. It will give you 105 plus 7. So 105 plus 7 will be 112. Now, if we'll find the prime factors of 112, prime factors of 112 will be equal to 2 into 2 into 2 into 7. That is 2 to the power 4 into 7. Okay, so you can see here the prime factorization of 212 is 2 to the power 4 into 7. So it is a product of prime factor of 2 and 7. That is, it has factors other than 1. You can see 2 to the power 4, that is 2 and 7 are involved. That means it has factors other than 1 and itself. Okay, 2 and 7 are its factor. And since 2 and 7 are factor of 112, so it cannot be a so hence it is a composite number. It cannot be a prime number. Okay, since 2 and 7 are factors of 112, so therefore you can say, therefore 3 into 5 into 7 plus 7 is a composite number. Okay, any doubt in this? That this is a very easy proof. Okay, that you have to just find out the exact number, and I have find the prime factor of that number. And since you can see that in the prime factorization of number, we have got 2 and 7. If we have got only one, which is not a prime number, so we cannot take it as a prime factorization number. Okay, if the number is 113 and it is only divided by 1 and except, then you can say that it is a prime number, it is not a composite number. But since we can see that 2 and 7 are its prime factors, so the number is a composite number, not a prime number. Okay, now another example, we may check that. Let's see another example. Check whether 4 to the power n, where n is a rational number. Now you have to check a number 4 to the power n, and n is a natural number. That means it can be 1, 2, 3, 4, any number, but it is not a negative number. Okay, can end with a digit 0 for any natural number n. So you have to check that 4 to the power n ends with a digit 0. Okay, for any natural number. Now, if a number ends with 0, so can you tell me, Rudronian, it can be divided with which of the two prime numbers? Since it is ending with 0, so the number is even. Yes, Rudronian?
Maybe 2 or 5.
Yes, 2 and 5. Since the number is ending with 0, so it's an even number, and even numbers are always divided by 2. And 5 also divides the number which ends with 0 and 5. Okay, with the divisibility test, we know that. So the number, if a number it is ending with 0, so it has prime factor 2 and 5. Understood? So let's see how we have an example. Okay. Now, since number is ending with 0, then it has 2 and 5 as prime factor. Okay. Any doubt in this? But you can say that you can see that 4 can be written as 2 into 2. Okay, 4 can be written as 2 into 2. Am I right? And you here in question it is 4n. So therefore 4n can be written as 2 into 2 to the power n. Okay, which you can say that it can be 2 to the power 2n. Okay, 2 to the power 2n. Now, if you can see here, it will be 2 square. So 2 to the power 2n. And so therefore 4n is equal to 2 to the power 2n. And this states that prime factorization of 4n does not contain 5. Okay, you can see here, we can see only 2 here as a prime factorization. So 4n prime factorization does not include 5. So therefore 4 to the power n does not end in 0. Okay, because if it is ending in 0, 5 should also be the prime factor. Okay, but as you can see that 4 to the power n is equal to 2 to the power 2n, so it will never contain 5 as in prime factors, so the number is not ending in 0. Understood?
Yes.
Any doubt in these two questions? And what is the fundamental theorem of arithmetic? So shall we move on the next topic? And let's see some of the examples on this HCF and LCM by prime factorization method. Now we are going to use the prime factorization method to find the HCF and LCM. Okay. Now here HCF and LCM, you already know that what are the HCF and LCM? HCF is the highest common factor and LCM is lowest common factor. Okay. So if you find if the numbers are given, if any number is given, okay, and you are finding the prime factors of the number that divides the number. Okay. So if you have two numbers and you have find out the prime factors of both the number with the least power, you are going to take in LCM the numbers with the HCF the least power. In LCM you will take the number with the highest power. Okay. For example, let's see a question. Find the HCF and LCM of 6, 72 and 120. Okay. Let's find the HCF of 6, 22 and 120. Okay. Now if you will find the prime factorization of 6, so it will be 2 to the power 1 into 3 to the power 1. It will find out prime factorization of 72. So it will be 2 into 2 into 3. So it will be 2 to the power 3 multiplied by 3 to the power 2. So these are the prime factorization of 6 and 72. Now let's check with the prime factorization of 120. So it will be 2 to the power 3 into 3 to the power 1 into 5 to the power 1. Okay. So now if you find the HCF of the three numbers, then in HCF you are going to take the least power of the numbers. So here 2 to the power 1 and 3 to the power 1 is the least power. Okay. So the HCF of 6, 72 and 120 is 2 to the power 1 into 3 to the power 1, that is 6. And LCM of, you will take the highest power of the numbers. So as you can see, 2 to the power 3 and 3 to the power 2 and 5 to the power 1 is the highest power. It is actually into 5 to the power 1, which is equal to 306. So this is the LCM of 6, 120 and 72. Okay. Any doubt in finding LCM and HCF? Rudronian, any doubt in HCF and LCM?
No.
Okay. If you have any doubt, you may ask. Okay. HCF means the highest common factor. Okay. The highest common factor. You can say the common factor that are present in odd. So 2 and 3 with the power of 1 are present in odd. Least common factor means the factors that are not only present in 1, but they have the highest power. Okay, you can say here. See here. Okay, sorry. In 6, 72, and 120, the power of 2 is 3. The highest power of 2 is 3. The highest power of 3 is 2. And the highest power of 5 is 1. So we are going to take 2 to the power 3 into 3 to the power 2 into 5 is equal to 360 is our LCM. Okay. Now, write the HCF of the smallest composite number and the smallest prime number. So can you tell me, Rudronial, which one is the smallest composite number?
Ma'am, it will be 2.
No, in smallest composite number. Smallest prime number is 2. Smallest composite number is? Composite numbers are the numbers that have factors other than 1 and itself. So the smallest composite number is 4. Okay, Rudronial? Because 1 is not a composite number nor a prime number. 2 is a prime number. 3 is a prime number. And 4 is the smallest even composite number. Okay, and smallest composite number also. So smallest composite number is 4 and the smallest prime number is 2. So we are going to find the HCF of 4 and 2. So what will be the HCF of 4 and 2, Rudronial? If you find out the HCF of 4 and 2, so the prime factors of 4 are 2 2s are 4, okay, and 2 is 2 1s are 2, from which 1 you cannot consider because it is not a prime number, okay. So you're remaining with 2 to the power 1. So it will be 2 to the power 1, okay. So 2 to the power 1 is the HCF of 4 and 2. Okay, Rudronial? Okay. Now I want that you find the HCF and LCM of 120 and 144. You can see the question on your screen. The last question, example 7. Find the LCM and HCF of 120 and 144 by fundamental theorem of arithmetics.
It's the HCF 24.
HCF is
24.
and LCM?
Ma'am, it's the sum.
You can take the highest power of the numbers.
It's 720.
720. Very good. Okay. So you have understood about the HCF and LCM, I think?
Yes, ma'am.
Yeah. So from this chapter, you will not get a maximum of 3 marks question. You can get 2 marks question and 3 marks, sorry, 1 marks question and 3 marks, because they are very basic types of question. Like you have to apply the fundamentals theorem of arithmetic. Then you have Euclid's division algorithm, Euclid's division lemma. Okay. So these are very simple questions. Okay. So you'll get a question of 1 marks or 3 marks from this chapter. So now example number 8. Let's see one more question. The length, breadth, and height of question is incomplete, I think, of are 8 meter 25 centimeter, 6 meter 75 centimeter, and 4 meter 50 centimeter respectively. Find the length of the longest rod that can measure the 3 dimensions of the room exactly. Okay, so now here you can see that the length, breadth, and height are given in 2 values, that meter and centimeter both, means 8 meter 25 centimeter. So you cannot find the LCM or HCF of 8 meter 20. So we are going to convert whole thing into 1 unit, that is centimeter. If you convert in meter, then it will be in points. So 8 meter will be equal to 800 centimeter. So the complete will be 825 centimeter length. Okay, 675 as breadth and 450 as centimeter. So 150 centimeter as in height. Okay, now if you find the HCF, it will be 75, as the required length of the longest rod will be 75. Why we have taken HCF? Because you have to find the longest rod that will measure the 3 dimensions of the room exactly. So you need to find the highest common factor between all the 3. So the highest common factor is 3 into 5 square. Okay, which will be 75. So 75 centimeter rod will be the longest rod which will measure the room. Okay, so these types of problems can come. Now there is a relationship between both LCM and HCF. Okay, what is the relationship between HCF and LCM? Let's see. Okay, now what is the relationship between HCF and LCM? Formula is HCF of, here the 2 numbers are A and B. Okay, Rudronial, 2 numbers are A and B. Now, if you find the HCF of A and B, if your HCF of A and B are given, and then LCM of A and B are also, okay, LCM equal to comma A and B, what will be it equal to? The product of both the numbers A and B. Okay, anybody has joined? Okay, so understood, Rudronial? HCF of the number A and B multiplied by the LCM of the number A and B is equal to the product of the number. So this is the relation between the HCF and LCM of the number. If you are finding the HCF and LCM of 2 numbers, the 2 numbers are A and B. Okay, this same formula you can convert for just for HCF. If you just, for example, if you need to find out HCF and LCM and the product of the number are given, so just the formula will convert it. The main formula is the formula that I have written above. Okay, it can be this. And if you same imply that if you need to find out the LCM of comma A by B. So what it will be? It will be again A multiplied by B by HCF A comma B. Okay. Now this was about two numbers, that if you have two numbers, okay, A and B, if you're finding the LCM and LCM of two numbers, but suppose you're finding out about finding the HCF and LCM of two numbers, then what is the relation between the HCF and LCM? If you have, so formula is different. If you have HCF of three numbers, if you need to find out HCF of three numbers and LCM and product is given. So it is A, the three numbers are A, B, and C. A, B, C multiplied by the LCM of all the three numbers, okay, divided by LCM of two numbers. First, you will take AB, okay, multiplied by the LCM of BC, then CA, okay, understood? And similarly, if you need to find out the LCM of three numbers, the relation between the LCM of three numbers, and it will be multiplication of all the three numbers plus multiplication of the HCF of all the three numbers. Okay, CF of A comma B multiplied by the HCF of B comma C multiplied by the HCF of C comma A. Okay, any doubt in the relationship, Rudroniya?
No, ma'am.
Now let's see a question and then we will close the class. Okay, let's have 2-3 questions and then we'll end the class. Okay, so if HCF of two number, the first question is very simple. It is given you that HCF of two number is 2. Okay, HCF is 2. Example 9. So HCF is given is equal to 2 and the product is 120 and A multiplied by B is 120. Now you have to find the LCM. So if you have to find the LCM, what is the formula? Product divided by the LCM. So if product will be 120 and divided by 2, so it is simple 60. Okay, Rudroniya? Similarly, let's see example number 10. So what is example number 10? Is the HCF of 35 and 45. Here A is given, that is 35. B is given 45. Okay, 35 and 45 is 5. HCF is also given. HCF is 5. LCM of 35 and 45 is 63 into 8. Now here in LCM, it is saying that LCM of both the number are 63 multiplied by A. So you have to find out this missing value of A. Okay, now here we will not take A because it will create a confusion. Okay, you can say X and Y. The two numbers are 35 and 45. Understood? Sorry that because of the light issue, you can see me. Okay, ignore that. Okay, now what is the formula? Yeah. HCF into LCM is equal to what? The product of two numbers, X into Y. Am I right? Okay, you have to remember the main base formula. Okay, HCF and LCM is equal to, so HCF and LCM multiplied, it is written as 5 multiplied by 63 multiplied by A, that is given to you in the question, and X is 35 multiplied by 45. Okay, so A will be equal to 35 multiplied by 45 multiplied by 63 multiplied by 5. Okay, so you can just simply divide it and get the answer. The answer is 5. Okay, so A is equal to 5. Okay, so this type of question can also come. Either they can be directly, if it's 1 marks, it can give you directly the value of LCM or LCM or the product, and it can ask you any other value, or it can give you a missing number in that and it want you to solve the number. Okay, and example number 11, let's see example number 11, and in your assignment you'll find some similar question also. You can find these questions also and some questions that are based on these questions. Okay, and try to do assignment because that will give you a good practice, and if you have any doubt in the assignment, you can ask in the group or in the next class. If HCF 28, 35 and 347 is 7, find the LCM of all the three numbers. Okay, so the numbers are given and it's telling you HCF is also given, you have to find the LCM. Now here there are three numbers. Okay, Rudroniya. So what will be the LCM? LCM of, now LCM of what are the three numbers? 28, 35 and 343 is what? According to formula, it will be multiplication of all the three numbers. Okay, and HCF all the three numbers, that is 7, that is given to you. Now LCM of 28 and 35, LCM of 35 and 343, and LCM of 343 and 28. The LCM of all the pairs are 7 into 7, 7. Okay, so your answer will be, you can solve this and you can find the exact answer. Okay, just 7 by 7, your answer. Okay, any doubt till here? We have completed the topic 3, fundamental theorem of arithmetic. Okay, Rudroniya, any doubt in all the topics that we have covered today or in the previous? Okay, so I'm ending the class here. Okay, and you will have an assignment based on this topic 3. Okay.
Okay.
Okay, bye bye.